Okay, we're looking at finding horizontal asymptotes algebraically, so these are the kind of problems you're going to see. Before we get into this, it looks complicated, but it's really not. I want to show you something in Desmos, and here's a typical graph. Let me zoom out a little bit. Here's a typical graph that you're going to see on these rational functions, and you can see this 2x squared plus 8x minus 10, x squared plus 6x minus 7 in the denominator. Okay, but I want to show you something about that. And you might have already picked up on it. See how it's curving off here and it's curving off here? Well, let me add this other line in there. See that dotted line right there? That is called the horizontal asymptote. And that is a line that the original rational function graph cannot cross this line, cannot go to it. It's approaching it. And you might say, no, Fisher, look at that. It is crossing. But if I zoom in enough, you'll see, no, it's not. It's not crossing. So let me get back to this. So that is the line that's left there, that dotted line, that's the horizontal asymptote, and that's what we got to figure out. And I want you to notice for the rational function that is the horizontal asymptote for, that the degree of this in the front, the highest degree of the leading coefficients, or the leading terms, I should say, is x squared and x squared. And the coefficients are 2, and down below it's an understood 1 right there. So I could put a 1 in there. So it's 2 over 1. And you see the line, the horizontal asymptote, it's 2 over 1. Now I didn't have to say 2 over 1. In fact, I'm going to take that one off, and I just want to show you, yeah, see that blue line? It's just y equals 2. So an equation like that, so I'm going to hop back over here to delta math, and I want to show you this one. So here's an example of what you would see. 3x squared, blah, 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 over x squared. See how the degrees are the same, the x squared and the x squared? Well, the leading coefficients, so here the leading coefficients is 3 over 1, so the horizontal asymptote is 3 over 1, or 3. And let me show a few more similar to that. Hang on, new problem. I want to show you just the kind that I explained. Here's, come on when you need it. All right, I'll get one in a second. Okay, so here's some that the degrees, how they're both x squared and x squared. All right, down the bottom. So the asymptote is the 9 over 6, which reduces to 3 over 2. All right, so it's just, if the degrees are the same, then it's those leading coefficients written as y equals, and it's a line. All right, so one more that looks like that, where the degrees are the same. These degrees are the same, x squared, top and bottom. And so it's y equals 1/2, or the leading coefficients, 1 over 2. All right, and so that's one kind of problem you're going to see. Another kind, let me hop back over here to Desmos and take these off. That was where the degrees were the same. Here's an example, and I hope you quickly see that the degree is to the 3rd power in the top one, and it's only to the 2nd power there. So we call that one top heavy. And the asymptote on that one for horizontal, well, it's actually not there. It's a very strange graph. And here's the graph of it. And I want to put in this diagonal line there. So it's what we call a slant asymptote. When it's top heavy, so to the 3rd power over to the 2nd power, we're going to get a slant asymptote and no horizontal asymptote. So take a look at the answers in delta math when it's top heavy. Let me find one that is top heavy. I'll find one in a second. There we go. So x squared in the top, just x in the bottom, and the answer is no horizontal asymptote. Easy enough. All right, let me find one more that's top heavy. Top heavy. Come on. Top heavy. Not that one, not that one, not that one, not that one. I'm going to click right through it when it comes. All right, come on. Top heavy. Boy, they're hard to find, apparently. All right, so come on. Here is one now. Nope, that's not it either. All right, well, the top heavy ones don't come up very often, apparently. And apparently never. All right, well, you'll see one in your work. Oh my goodness, come on, top heavy. There we go. There's a top heavy one, so it's x squared in the top and just x to the 1st in the bottom. So there's no horizontal asymptote. There is a slant asymptote, but we're not concerned with that. Okay, now let me jump back to my last example, and then we're done. All right, so you were not responsible for figuring out what the slant asymptote was in that last one. just that there's no horizontal. Now here's one. Oh, let me zoom in a little bit. All right, so here's a rational function, and zooming in on that guy. And then look at the horizontal asymptote sitting right there, y equals, well, it's y equals 0. Okay, so it's not the leading coefficients, because if it was, that would have been y equals 1 over 1, but it's not that. So this is when it's bottom heavy. And look at the degree of the top. It's to the first power, and the degree in the bottom is just to the second power. So that's bottom heavy is what we call it. And I kind of think of bottom heavy. Well, something's bottom heavy is probably going to sink to the floor. And I'm calling y equals 0 the floor. So see that right there? I'm calling y equals 0 the floor. So when it's bottom heavy, it's y equals 0. Look at a couple of examples in delta math and we'll be done with it. So here's one that's bottom heavy because it's 3x. Doesn't matter about 3. 3x to the what? First. 2x squared. So it's bottom heavy. The degree of the denominator is greater than the numerator. So it's at y equals 0. So it's always at y equals 0 if it's bottom heavy. There's the same. They're taking the leading coefficients. And here is the same. They would do the same thing there. Here's one that is the same. So they're taking the leading coefficients. And then finally, come on, give me a bottom heavy now. Now, see, it won't give me a bottom heavy, and it would before. There was a top heavy. Here is an example of, come on, delta math. Now you're starting to make me mad. I'm joining the ranks of the students that are angry about it. Here's one that is bottom heavy. So because the degree is squared in the bottom, it's only to the first and the top, so it's y equals 0. Okay, good enough.